Congratulations to the Gigabyte team on the Ampere Altra lineup. We're proud to have worked closely with you in bringing an innovative new line of cloud and edge servers to the market. The innovation of the cloud-native ecosystem has ushered in a new compute model that allows DevOps to seamlessly deploy and scale services on vast infrastructure. This ability to scale out in an elastic manner has been a major reason for the continuing growth of the cloud. It is critical that the underlying hardware enable the desired elasticity, resiliency, automation, and portability required by cloud service providers and cloud-native developers. For this, you need the right type of CPU, one that delivers predictable high performance, platform scalability, and power-efficient compute density. This is why, at Ampere, we have built what we call the world's first cloud-native processor, Ampere Altra. Ampere Altra delivers predictable high performance with maximum cores, up to 80 in a single processor. In addition to providing each core with large caches and memory bandwidth, each core has been specifically optimized for consistently high performance across many different workloads, regardless of the number of users. This means that a cloud service provider can deliver industry-leading performance all of the time to their users without worrying about degraded service. Ampere Altra delivers platform scalability. As more cores are brought online, performance scales linearly. Combined with maximum network and I/O bandwidth, this results in the highest performance scaled out across the server, rack, and data center. Being able to scale performance to meet increasing demand provides the elasticity that cloud service providers require. Our products also deliver power-efficient compute density. By optimizing our processors for the highest performance per watt and the lowest power per core, Ampere Altra is the most efficient data center processor. This allows cloud service providers to deploy more cores and more CPUs, meaning more capacity in the same rack and data center footprint. Together, this results in not just the ideal processor for the cloud, but also the lowest total cost of ownership in cloud. But why does this really matter? Let's consider a microservices-based application like ride-hailing. There can be thousands of individual microservices running, which provide everything from matching the rider and driver, to mapping the ride, to billing when the ride is completed. These must scale based both on the complexity of an individual ride and the number of concurrent rides occurring. When building the overall service, you want the rider's request to complete as quickly as possible every single time. You want to be able to scale up and down with the number of riders, and you'd like to do so within an existing data center footprint at the lowest possible total cost. This is where Ampere Altra shines, with the ability to distribute these microservices across many high-performance and efficient cores. These are the highest performance processors, and they're available to anyone building or running in a cloud, from hyperscale to edge. Now that I've told you about the Ampere Altra processor and the way that we've designed it for the needs of the modern cloud, it's time to look at the actual data to prove how well it performs. The Ampere Altra processor and its 80 cores outperform the 64-core AMD EPYC processor and the 40-core Intel Xeon processor, providing leadership performance across all the performance-sensitive workloads in the cloud. Ampere Altra beats AMD EPYC by 26% on Memcached and 44% on Redis. And for web serving with NGINX, where density really matters, Ampere Altra delivers 36% more performance per watt. Whether you're interested in running a database, encoding videos, or executing an AI model, Ampere Altra provides scalable and efficient performance leadership. CI/CD is a major part of cloud-native computing, and Ampere has embraced it in our development process. Each night, we run regression tests across a host of operating systems, program languages, and applications to ensure that the out-of-the-box performance of Ampere processors doesn't regress when new code is released. For transparency with our users, we publish the daily results on our publicly available Ampere Solutions portal. We continuously optimize applications for our Ampere processors to ensure that both our current Ampere Ultra processors, as well as all future processors, run at peak performance with full compatibility across all processors. All this work is upstreamed and made available freely to our users. When it comes to the servers themselves, standardization and interoperability are extremely important. Our processors are SBSA compliant, ensuring operating systems can boot and infrastructure can be managed in a standard way. We're pleased to have a strong collaboration with Gigabyte, developing a wide range of servers for compute, storage, and accelerated computing, both in the cloud and at the edge. The initial Mount Snow platforms, which are ARM System Ready SR certified, have been shipping to customers for over a year from Gigabyte. The R272 provides support for up to 24 drives in a 2U form factor, making it a versatile choice for a range of workloads, while the R152 is a denser 1U form factor for maximum compute in the rack. For more specialized deployments, the E252 is an excellent choice for edge deployments, and the G242 supports up to 4 GPUs for accelerated workloads from AI to media. Thank you, Gigabyte, for your support, and I look forward to additional Ampere-based Gigabyte servers on this and future generations.